Page 15. It relates to yesterday's homework and also what you guys did last week on parallel and perpendicular lines. Okay, so first off, graph y equals 3x plus 2 and y equals 3x minus 2. What's similar between these two lines? So without even graphing, you probably see it already and you know the answer. But let's just recap because we talked about this last week. Okay, so y equals 3x plus 2. My slope is 3. My y-intercept is 2. Okay. Okay, and then the second line, y equals 3x minus 2. My slope is 3. My y-intercept is negative 2. So y-intercept at 2, up 3 over 1, up 3 over 1. Alright. Notice how fast I drew the two lines. That's how fast you should be drawing your two lines on the assignment or test. Okay. Yep. Sure. Here you go. What do you notice? Sure. Here you go. That works. Okay, what do you notice about these two lines? Ivan? Other than, okay, and you're gonna tell me as well. You're gonna, what do you notice about? Okay, good. Both positive slopes. More importantly, they're parallel. Okay, what mathematical number tells you that they are parallel? Okay, so graphically, yeah, they look like they are parallel, but mathematically,
they have the same slope.
same slope.
The two numbers.
Right.
Just negative and positive.
Yeah. So does y-intercept matter? No. Okay. So same slope means they're parallel. Okay. Or parallel means same slope. Okay. So this is what we figured out last week. Okay. So this is just a quick reminder. Okay. What about this one then? Y equals 2/3 x minus 1. My slope is 2 over 3. Y-intercept is negative 1. So let's graph these two. Okay. And again, graphing the lines now should not take you long. Okay, so negative 1. And then my slope is 2 over 3, so up to 3 to the right. Okay. And I get this line. Okay. That's how fast it should take you to draw the line. And then the second line, negative 3 over 2x plus 4. M is negative 3 over 2. B is 4. So plot the 4. 1, 2, 3, 4. My slope is negative 3 over 2. So that means from that point, I'm going to go down 3. 1, 2, 3. And 2 to the right. I can do that again to get a more accurate line. 1, 2, 3. 2 to the right. Okay, and just like that, I have my second one. Okay. What do you notice about these two lines? Sophia? Perpendicular. And what can you say about the slopes? Sophia? Excellent. Okay, so notice the slopes, 2 over 3 and negative 3 over 2. So they have negative reciprocal slopes, which means The lines are perpendicular. I'll zoom out. I'll zoom out in a bit. Okay. What is that angle? When we say two lines are perpendicular, the angle is 90 degrees. So this angle right here is 90 degrees. Okay. So given y equals 3x plus 5, can you tell me any equation that is parallel to this? Alvin. Good. Okay, another one. Jasmine? Any other line that's parallel to this? 1 second. Y equals
3x minus 5.
Sure. Okay. What about y equals 3x plus 5? Can I have y equals 3x plus 5? No. Okay, because then it will be exactly the same line. Okay. Max, your question?
So, for the previous two graphic questions,
Yeah.
I know that the first one is parallel and the second one is perpendicular, but it doesn't look parallel.
It parallel. So notice with this one, it goes up 3 over 1, up 3 over 1. This one, same thing. Up 3 over 1, up 3 over 1.
I know, but it just doesn't look parallel.
Did you miss one of your points? Maybe one of your points is off? I'll take a look at your graph after, but it should. Okay, and then for perpendicular, if I want an example of a line perpendicular to that, Margaret?
Y equals negative 1 over 3x plus 5.
Good. Okay, can it have the same y-intercept? Yes. Okay, so they could cross at the same at the y-axis, right? So yes, in this case, you can have the same y-intercept. Okay, another line that's perpendicular to y equals 3x plus 5. Bessie?
Y equals negative 3x minus 2.
Okay, y equals negative 3x. So you did the negative, but you didn't do the reciprocal.
Negative 1 over.
Right. Okay, so make sure it's negative and reciprocal, not just one or the other. Okay. So this is basically what we talked about last week when you guys did that partner activity together. Now, example 2, this ties into what we did yesterday. Okay, write an equation of another line that is parallel to this, but also passes through this point. So basically you have, like if I were to do a little sketch, you have this line right here. Okay, that's this line. And then you want a second line that goes through the point -2, -6, and that's parallel to it. Okay, so you basically want to find the equation of the second line. So ideas. So this ties into yesterday's. Yep.
I think you can find out um, how how many steps the dog goes up or goes right or left.
Okay, so when you talk about like how many steps it goes up and to the right, what are you referring to? The slope, right? Yeah, when you talk about the rise and the run, you're basically talking about the slope. So what is the slope in this line? 3. And since it's parallel, it means that for my new line, I also have a slope of 3. Okay. Now, isn't this just like yesterday's work? Given the slope, given a point, how do I find the equation? You did your homework yesterday. y equals mx plus b, right? This is my x, this is my y, this is my m. I substitute everything. So y is -6, m is 3, x is -2, and I solve for b. Okay, so -6 equals -6 plus b. Okay, so what does b equal? Yeah, 0. Okay, so my graph is a little off. Okay, so what is the equation of the red line? Y equal, Sophia? Huh? The equation of the red line?
Plus 3x plus 0, or just 3x.
Perfect, right. Okay, so y equals 3x plus 0. On the test, on the assignment, don't write that plus 0, just write y equals 3x. Okay, so this is what we did yesterday, but yesterday I told you what the slope is. Today, you have to see the implication. So I'm telling you indirectly. Okay, because I said it's parallel, that means you know the slope is 3. Okay, so similarly now, okay, I have this equation right here, and I'm saying the slope is perpendicular. Okay, so what do you think is my very first step? My very first step. Yep.
Rewrite that into y equals to mx plus b4.
Perfect. So rearrange it, because just looking at this, my slope is not 3. I have to rearrange this equation to y equals mx plus b form. So I'm gonna have move the 3x over, becomes -3x. Move the 40 over, becomes -40. Right? Don't forget, I have to divide everything by -5. Here, I'll rewrite it out like this. Okay, because I'm dividing everything by -5. So when I clean it up, 2 negatives make a positive, so 3/5 x. 2 negatives make a positive, so plus 8. Okay, on the test, that will give you 1 mark. Okay? Because I haven't really answered anything about the second line. Okay? This is still my first line, the blue line. So what am I gonna take out of this equation for my red line? The m, yeah. If the slope of this line is 3/5, then the slope of my red line is gonna be, which is? Perfect. Good job. And it has the same y-intercept, so b is 8. Yeah. It has the same y-intercept, but negative reciprocal slope. So therefore, the equation of my red line is, Angelina? Perfect. Oh, and on the last assignment, some of you wrote -5/3 plus 8, and that x disappeared. It's another silly mistake, careless mistake. Okay. So sometimes students get confused with the question because they're thinking, find the equation, but I'm given the equation. You're finding the equation of the second line. Okay, so that's why, and I know that's why some people get confused. Okay. What about this one? Write an equation of a line parallel to the x-axis that passes through 2, 5. These ones right here, where it's parallel and perpendicular to x-axis, y-axis, these ones, the easiest method is to sketch a graph. Okay, these questions where it's because perpendicular or horizontal, parallel or perpendicular to axis means you're talking about horizontal or vertical lines, and so mathematically it won't work. Okay, so I'll do a quick little sketch. Okay, so let's say that's my axis right here. I want to write an equation that is parallel to the x-axis. So am I talking about a horizontal or vertical line? Parallel to the x-axis, so it is horizontal. Okay, so horizontal line that goes through 2, 5. Oops, I'll just say it's there. I drew it too high. So I'm looking for the equation of this line. And what is the equation of that line? Horizontal line. What's the equation? Yep. Yeah, that's it. So the equation is just simply y equals 5. Okay, so no calculations involved. Whenever it says parallel or perpendicular to an axis, you know that it's just do a quick little sketch and you will get your answer. One, two, three, four, 5. Yeah. Okay, this is a 5 right here. Okay, and then similarly with this one, I want it to be perpendicular to the x-axis, and it goes through the point -4, -5. So do a quick little sketch. Here, I'll do this. Okay, I know that it wants to go through the point -4, -5. So this point right here. Okay, so perpendicular to the x-axis, am I talking about a horizontal or vertical line? Perpendicular to the x-axis. Perpendicular. So this is my x-axis. Perpendicular to it means vertical. Okay. So this way, I'm looking for the equation of this red line. And where does it cross? Okay, what's the equation of this line? Let's see, Margaret. What's the equation of this line?
X equals -4.
Yep, -4. Okay. So these questions, I didn't have to do any of this calculation to find M, find B, because it's not a diagonal line. So whenever it's a horizontal or vertical line, easiest way is just to do a quick little sketch. Okay, I just drew it with a scale and everything, but on the test, you can just do a quick 1-second sketch on a scrap paper, because I just want you guys to see if it's vertical or horizontal, and then you would be able to tell what the answer is. Okay, last example. Given these 3 points, show mathematically whether the points form a right angle triangle. Okay, so do I have to graph these 3 points? No, but I could do a quick little sketch, because again, it will help me see the big picture a little better. So -4, 7, so that's A, -8 and 0, that's right here, that's B, and then 6.5 and 1, that's C. Okay, I know that it's supposed to form a triangle. Okay, does it look like a right angle triangle? Okay, but which, but it does say show mathematically. So maybe it's just my sketch is ugly. All right, but looking at this, which angle looks like it might be right angle? A, right? So I can check to see if that's 90 degree. So I'm not going to take out my protractor because we don't use it anymore. So based on today's lesson, how do we check if it's perpendicular, if it's 90 degree? Yep.
Use m equals y2 minus y1 over x1, x2 minus x1.
Okay, but okay, yeah. So what are you comparing?
I'm comparing back to B versus B to C.
What about A to B and B to C?
Like if you determine the formula.
What formula? What formula is that? Yeah, the y2 minus y1 over x2 minus xy. What formula is that for? Slope, right? So that means you want to compare the slopes to see if they are perpendicular, if they are negative reciprocal. Okay. So this question again, it's what is it implying? What are you trying to do? What are you trying to solve? So as Jasmine says, I like that idea. So let's compare the slope of AB, which is y2 minus y1 over x2 minus x1. So plug in the coordinates of A and B. Okay. So y2, doesn't matter which one you say is the first point, which one you say is the second point. So let's say 0 minus 7 over -8 minus -4. You get -7 over -4. So 7 over 4. Okay. Now I do the slope of my second line, which is the slope between A and C. Okay. Between A and C, so y2 is 1, y1 is 7, x2 is 6.5, x1 is -4. Okay, so I can use decimal in here because my question had decimals. So I get -6 over 10.5. Okay, so are they negative reciprocals of each other? Okay, but of course, I'm adding in a little trick. Okay. Well, Max sees it. Max sees something. I think Sophia might see it too. If I were to, because remember how I say I hate decimals with fractions together? So, okay, yes, you could use a calculator. Or if I multiply everything by 2 here, this is the same as -12 over 21, right? If I times this by 2, I get -12 over 21. Can I reduce this?
Yeah, with 3.
Yeah, and so what do I get?
-4 over.
Oh! So are they negative reciprocal? Yes. Which means it is a right triangle. So therefore, it is a right triangle because one of the angle is 90 degree, is a right angle. So it's a right triangle. Okay. So this one is a little tricky, okay, because you know what you were looking for, but when you looked at this, yeah, it doesn't look negative reciprocal. But then if you play with that fraction. Okay, these are all equivalent ratios, equivalent fractions. These are all proportional. So when you multiply and divide, you realize that, oh, they are. Okay? So this is kind of like a wrap up of what we did yesterday and what we know from last week. Okay, so try the next 2 pages, please. Page 17. Let me see. Page 17, 18, and 19. Yeah, and then answers are on page 20. So tomorrow, we're just gonna do the short assignment, and then we're gonna finish off with the last section, which is motion graph. Motion graphs is pretty easy. It's analyzing graph again. So after your assignment, we'll just finish off the chapter with that, and then that's everything you need to know for lines. No more lines. No more no more linear relations after that. Okay. So page 17 to 19.